Hello, everybody. Today we are going to be going over vectors, some simple basics about them. I am happy to be back for summer of 2024. I will be posting a lot more videos now that I am off of break, and I am ready to assist everyone this year. So, first, vectors, essentially, what it's going to be is let's say we have a space. I mean, in this case, we're going to use coordinate system, and then we have obviously obviously tick marks. This is the x and y axis. You obviously see. Let's say this is 1, 2, 3. This is obviously not to scale. 1, 2, 3. So a vector is essentially a point, let's say 0, 0 for this case, and then an array that extends out from that point. So in this case, this vector here starts at 0, 0, and then goes to 2, 2, because this is where the ray ends. Where this ray ends does matter on the classification of this vector. So, for this vector, there's a lot of names you can give a vector like this. In this case, there's this name, which is 2, 2 in the brackets, the 2 meaning the x component and the 2 meaning the y component. So that means the x goes first. So x, y, essentially. There's also 2 j hat. So there's 2 I hat plus 2 j hat. This is essentially just an I and a j, but with a triangle top. And this is used more in vector calculus, but you will see this notation in sometimes. And essentially, it's just going to be in the form. X I hat plus y j hat. And then obviously in the third dimension, there's there's also another variable, z k hat. So yeah. And then another vector classification you're going to get is the standard point system, which is these kind of greater than or looking to less than symbols. This is also a classification of the vector as well, and this is in the form x comma y, the x and y component of this vector. So this is how we classify one of these vectors. Now let's write an example. Let's delete this vector, and let's make a vector in red. Let's say we have this vector. Hold on, actually, I'll choose a different one. Maybe, okay. How would you classify this vector in all systems? I'll give you a moment. Pause the video if you need more time. All right, then. Well, we have our first system, which has to do with us classifying it with the brackets. So we have the x component being 1 and the y component being 2. So this is the first classification. Next is we have the other vector classification. We have the x component being 1. So if we put it in I hat form, it'll just be I hat plus 2 k, or not k, that's 3 dimensions, plus 2 j hat. So this is another form of the vector. Now the last form, remember those vector symbols, we're going to have the x component, which is 1, and the y component, which is 2. So those are all three ways to represent this vector. Now, let's get into magnitude of vectors. So the magnitude of a vector is essentially going to be the length of the vector in this case. So if we call this vector, we're gonna give this vector a name. Let's call it A. And when we label vectors, we're going to put that symbol on top of them. Essentially, it's array. So here we want to use just normal color here. So for the magnitude, which is noted by these double bars, the magnitude of A is equal to just the square root of x squared plus y squared. Now, you may recognize this from the Pythagorean theorem, which says that a squared plus b squared equals c squared, but we just simplified it down. Essentially, this is going to create a right triangle here. So here, if we remove this this lettering here, remove this lettering, it essentially is going to create a right triangle. Here, I'll denote it in blue. If you see, there's this right triangle that this vector creates, and we can find its magnitude by using the quadratic formula. So we're going to find the we're going to have to use the x component, and then we're going to have to use the y component, essentially. So for this vector specifically, we're going to have the magnitude of A is equal to the square root of our x is 1, so 1 squared, plus our y component's 2, so 2 squared. So in this case, the magnitude of A in this case is going to equal the square root of 5, which is 4 plus 1. So that means that this vector is root 5 units long. So in this case, we'll just say units long. Yeah, so that is the length of this vector. We'll try another one without the visual representation, and let's see if you're going to be able to solve this one. Here, I'll keep the old example up. I'll just move it over. There we go. So for this one, essentially, we're going to have a vector. I'll give it to you in this form. Let's say we have a vector 3, 4. Okay. What is going to be the magnitude? Let's say this is equal to vector b. We got to find the magnitude of b. What is going to be the magnitude of b? I'll give you all a moment to solve this problem on your own. All right, just pause the video if you need any more time. In this case, what we're going to do is we're going to take, obviously, our square root, because remember our vector magnitude formula. That's going to be a squared, which is, or at least x squared, which is our x component is 3, so 3 squared, plus our y component, which is 4 squared. I'm going to put it all into a square root. So the magnitude of b is going to equal the square root of 9 plus 16. Now let's just simplify everything. This is going to be equal to square root of 25. And the square root of 25 is, in fact, a perfect square, and the magnitude in this case is 5. So that is the magnitude of vector 3, 4. Oops, that's not what I meant to do. Yeah. So, all right. Next, we're going to go on to some basic vector addition. Let's actually, in fact, we'll even keep I'll even keep. We'll write a new vector actually. I believe. Yeah, we can test out a new vector. Obviously, the numbers can get as complicated as they want, but in general, these are just the general things you'll see when it comes to vectors. So let's choose a vector. Let's make it. Um, let's make it purple, dark purple, and let's choose a vector. Oh shoot, that's a little bit too dark. Um, no, I'll choose green. I'll choose very light green. There we go. So let's say we have a vector here, and we want to add it with this other vector. Let's make it a little more, let's make it red. All right. And we're going to try to add these vectors together. And you'll be able to see and visually represent what that means. So if we have here vector A, let's call the vector A the red one and vector B the green one. So let's identify first. So we're going to have vector A, which is going to be, well, if you look at the x component, it's 1. If you look at the y component, it's 3. We're going to have an addition of this vector, which has an x component of 3 and has a y component of 1. So when we add these vectors, adding and subtracting vectors is just going to be the same as just adding and subtracting all their components. And this also transfers through all the systems, including the I-hat system and the other systems. So if we just add the components together, x component plus the x component is going to be 4. So it's just going to be 3 plus 1, which is 4. And then we have 3 plus 1, again, is 4, because we add the y components together. And this is going to be the addition vector. Now, what is this going to look like relative to the other vectors? But let's see. If we extend things out here, I know it's a little bit not exact, but when we get this new vector, essentially what's going to happen is we're going to have a vector with that has an x component of 4 and a y component of 4. Oh shoot. Yeah, I guess we'll make it bright blue. In this case. So you see that this vector has a larger magnitude than those other two vectors. That's because when we added them, the vector's magnitude increased. So if we get the magnitude of these two original vectors, they're both 2 because they have a y component or x component of 1 and a y component of 3, and 1 squared plus 3 squared, or sorry, it's square root of 10, is both their magnitudes. But if you use this 4 root 4, or not 4 root 4, if you use this 4 vector here, you have the square root of 16, which is 4 squared, plus 16, which is equal to 32 under a square root. So essentially that's going to be 4 root 2 is going to be the magnitude. So if the magnitude of this is equal to the square root of 10, and this is going to be equal to the square root of 2, or it's going to be equal to 4 square root of 2. So you could see that the magnitude has increased significantly, and then you can also see it graphically that the magnitude has increased as well. So that is how the addition of vectors works. Now, let's move on to subtraction of vectors. All right. I will remove. I'll probably remove these vectors and make new ones. And I'll probably yeah. Actually, I'll do the longer way, I guess. All right. Let's. Shoot, I didn't mean to do that. I'll do a red vector. Okay. Don't worry about the preciseness. It's not really an issue. Okay. So we have these two vectors here, and we're going to subtract them. Essentially, all we have to do is we essentially just have to subtract their components. So our first vector, let's identify it, is going to be the green one, the bigger vector. We'll call it. We'll say the bigger one's the first one we're gonna use, and that vector has an x component of 4 and a y component of 2. We're going to subtract this vector with an x component of 1 and a y component of 1. So we're just going to subtract the parts. So the x part of the first minus the x part of the second is just going to be 3. The y component of this one and minus the y component of the other one is going to be 1. So this is 3, 1. That's going to be the vector that is the subtraction of the two. Now let's graphically see how that is going to happen. Oh shoot. I guess. Oh yeah, I need color. That's why. So let's choose yellow. For this one. 3, 1. Yes. This would be it. So obviously the vectors aren't very close, but as you can see, it was subtracted from. As you can see, this length here, this vector, was subtracted from this vector, so the magnitude decreased a little bit by just as much as this vector. So this vector's magnitude minus this vector's magnitude is going to have this vector's magnitude. Another way to represent this vector is to slide this vector up where this one was and over where this one was. This vector is going to equal this. It's going to be the same as a minus b. This vector is going to be a minus b, where a is going to be this big green one and b is going to be this red large or this red small one. So that's how you subtract vectors. Try an example with no graphic. I will give you a simple vector to subtract. Let's say we have if we switch to white, switch please. Yep. Okay. So let's say we have a vector 5 5 4, and we're going to subtract vector 6 1. How are we going to be able to subtract these vectors? I will give you a moment to solve it by yourself. All right. So how this is going to work is we're just going to subtract the x components, subtract the y opponents. So it's going to be 5 minus 6, which is -1. And then we're going to have 4 minus 1, which is equal to 3. So this is going to be the vector that has the subtraction of these two vectors. Obviously, you could write it like this as the vector. Anyway, I hope you like this video, and I will definitely be posting a lot more since now the school year's coming up, and I know all y'all are going into your classes, and it'll definitely be a good time. And I'm going to be uploading even more videos and stuff for y'all. So um, I hope everyone had a great day, and goodbye.